Section 1.9 is about making and using formulas. You're probably somewhat familiar with this concept. A formula is an equation that relates variables, just like f of x is equal to y. But generally, when we talk about a formula, it's describing a specific quantity in the real world. So I'm giving you an example here. The volume of a square box is related to the length of its side, right? That is you get an equation out of this that relates the volume to the length of the side. So if it's square, that means that its width, its height, and its depth are all x. So x by x by x, meaning that the formula for the volume would be given by x cubed if x is the length of the side. And so then you could use that formula given a side to find the volume, or given the volume to find the length of the side. We can use this idea to construct another formula. So for an example, if Patty buys 4 pounds of apples and it costs her $5.88 for those 4 pounds, what was the cost of those apples per pound? In order to construct a formula, we need to first figure out, okay, well, what's the rate here? So what is the cost of these apples per pound? And so I can take the total cost and divide by the number of pounds to figure that out, right? So cost per pound will be the cost divided by the number of pounds, which gets me that $5.88 divided by 4 pounds. And so if you simplify that expression, you're going to see that the cost per pound is equal to $1.47 per pound of apples. So that would be the rate in terms of the formula. If we wanted to then construct a formula, given this information, then we could say that the cost of the apples could be given by C, and the weight of the apples will be given by W for weight, cost, weight, and then the only thing that we really need to figure out, or that we just found, was the rate, which is the price per pound of apples. So I'll call that P. Now what you do when you build a formula is you define your variables. So that's what we did. We defined the cost of the apples, that's C, the weight of the apples, which will be W, and the price per pound of the apples. So that's the rate of that cost, P. So the total cost that we will pay, which is for her the $5.88, is C. The weight corresponds to the number of pounds, the 4, and the price per pound, P, was the $1.47 that we calculated using the initial information. So to construct the formula, we say that the cost that we spend on these apples is going to equal that price per pound times the number of pounds that we have. So the formula is C is equal to P times W. The next concept here is when you have variables with subscripts, which is only going to happen if you have the same thing that you multiple times. So what I said here is if we have 2 or more of the same item, we need to distinguish which one is which. We have to do this by using subscripts, because if they're the same thing but they were taken at different times, for example, if we're measuring the number of ducks in a pond each day, then we're going to have several data points that are measuring the exact same thing, but they can be distinguished by which day we're measuring. So I have a set of data here for days numbered 1, 2, 3, 4, 5, 6, 7, and then the number of ducks that were in the pond on each of those days. So we can refer to each of these data values using subscripts. So this is a number of ducks, which means that I would naturally want to call it D, but I have 7 different measurements. So the number of ducks on day 1 would be D sub 1. The number of ducks on day 2 would be D sub 2. The number of ducks on day 3 could be D3, and so forth. D4, D5, D6, D7. And so if I'm going to construct a formula to compute the average number of ducks on these 7 days, the formula to compute that average number, so let's say I want to call that just A. So average number of ducks, we will call that A. Then A can be constructed using the variable names that I've defined for the data points that we do have, which is, it's really just going to be the number of ducks each day added up and then divided by the number of days, right? We did average 2 weeks ago. So I have D1 plus D2 plus D3 plus D4 plus D5 plus D6 plus D7 all over the number of days, which is 1, 2, 3, 4, 5, 6, 7. And this is a formula to determine the average number of ducks over those several days. We can actually compute what that average is because we have the data set, right? So 3 plus 5 plus 2, that makes 10, plus 4 plus 2 plus 3, that's another 9. That gets me an average of 19 over 7 for the number of ducks in that pond over the course of those several days. Now, since it's an average, we're going to have to round this, right? This gets us approximately 2.71 ducks, which means that obviously you're not going to have 2 and almost 3/4 of a duck. That's not going to be sensical, but you could say that it's going to be approximately 3 ducks on any given day. The last topic in 1.9 is reading formulas. So if I give you a formula, or you were given a formula maybe in your major, being able to evaluate it appropriately so you know what all the pieces mean, and you understand, given the equation, how they relate to each other. So the example that I'm going to use is the ideal gas law, PV equals nRT. In this case, if you've ever seen it before, P is corresponding with pressure. V is volume of a specific gas, right? It's the ideal gas law, so we usually use it with gas. So this is a volume of the gas. N is the number of moles of the gas that you have. R is the gas constant for the specific gas that you're working with. And T is going to be the temperature of that gas. So it's really important that you recognize that we name these variables based upon what they're representing, right? P for pressure, V for volume, N for number, G or R in this case is a little weird, right? It's the gas constant. You kind of want to make it a G, but it is R. T for temperature. Most of them make sense, at least, right? The important thing to be able to do once you have the formula is that if they ask you for a specific thing in the given this formula, you should be able to solve for any of these variables. And you can. Now, since R depends upon the gas that you're using, you're not usually solving for R, but we can solve for all of the other ones. If I wanted to determine P, all I would do is divide both sides by V. Right? Dividing by PV by V gets me P back, and then I just have nRT all over V. I can also isolate V if I want, right? V, if I just divide both sides by P, I have V is equal to nRT over P. Similarly, I can find the number of moles, N, by dividing both sides by RT. So I have PV over RT. And if I wanted to determine the temperature, T is equal to PV over nR. All of these correspond to the same formula. They all come from the initial formula of PV equals nRT. So when you're given a formula, you can use your algebra skills to convert it and solve for whatever variable you're actually trying to determine. Are you trying to find pressure? Are you trying to find volume? Are you trying to find the number of moles? Are you trying to find temperature? And in these cases, you can solve for any of those things given the rest of the variables.